Hello. So today we are here to discuss one new problem, and before discussing that problem, I want to give one example so that we can have a good discussion. And let's for that consider this is example 1. We'll consider this function. Okay, and with the help of this function, I'm going to create a sequence as this thing. Okay, and what does this mean? This means that if n is 1, then fn, the sequence, the first term is fx, right? If n is 2, then f2 is nothing but 2x over 1 plus 4x square. If n is 3, then we get f3 equals to 3x over 1 plus 9x square, and so on, right? We see that as n goes to infinity, fn goes to 0, right? Right? And this nothing looks new till now, right? But if we want, let's write in red, but if x goes to infinity, then what happens? Then also the function goes to 0, right? So here we can see that we have one connection between the sequence and the function, right? The same thing can be done for second example. Let's say if we have fx equals to x multiplied by e to the negative x, right? And the function, both of them are mapping from 0 to infinity to 0 to infinity. And also note that both of the functions are continuous. So over here, if we define a sequence like this, then we can see that as n goes to infinity, fn goes to 0, right? And again, we see that if x goes to infinity, then f goes to 0. So there we see that we have some connection between the sequence, which is fn, to the original function, right? If n goes to infinity, the sequence goes to 0, and if x goes to infinity, the function goes to 0. So we see that we have some connection between these two things, and we'll try to prove these things in our next video. So what we have till now, we have a continuous function from 0 to infinity to 0 to infinity, and the sequence which is defined in this manner. Make sure this is very important. The sequence defined in this manner goes to 0 as n goes to infinity. Okay? So we have to prove that f goes to 0 as x goes to infinity. We'll see this proof in our next video. Okay?